I chose to do the Pythagorean theorem because I'm very interested in the Pythagorean theorem and I love to teach it. It basically says that you have to have a right triangle, and it's, in layman terms, leg squared plus leg squared equals the hypotenuse. So I started with a right triangle where A was the right angle and BC was the hypotenuse. Then I constructed a square on the side of the hypotenuse, which were all 5 inches. Then I constructed a square on the side of the leg, which was 3 inches, and another square on the other side, which was 4 inches. I decided to draw a parallel from A to ED, I decided to draw a line from A to the line ED, creating AL, which is parallel to BE and CD. Then I drew another line from A to E, and I drew a line from F to C to show that square GB is equal to parallelogram BL, and square HC is equal to parallelogram CL. Basically, this proves that square GB is double the triangle FBC because they have the same bases and the same parallels, and that parallel BL is double triangle ABC, and doubles of equals are equal to one another. Since angles BAG and BAC are right angles and G and C meet at A, they make adjacent angles equal to the right angles. So angle FBA is equal to angle DBC because they're each right angles. You can put them together by ABC. Therefore, the right angle, or the whole angle FBC is equal to the whole angle ABD. And FB is equal to BA and DB is equal to BC. So those are two sides that are congruent. And so therefore we can prove that triangle FBC is equal to triangle ABD by side angle side. Again, we know that parallelogram BL is double triangle ABD because they have the same bases and the same parallels. Square GB is double the triangle FBC because they are on the same base and same parallels. And doubles of equals are equal to one another. Therefore, the square GB is equal to the parallelogram BL. And we can do the same thing to show that square HC is equal to CL. Therefore, the whole square, all the squares are equal to one another. Proving that in a right triangle, the square is drawn on opposite. Therefore, proving in a right triangle, the square drawn on the opposite side, the right angle is equal to the squares drawn on the sides of the other one. Here is an example of the Pythagorean theorem using numbers of 3, 4, and 5. And 3 and 4 can be switched because leg and leg are basically the same thing, and then the 5 is the hypotenuse.